Hi guys, Miss Monserrati here. You can't see me. Hi. But you can see my page. I'm going to try and do a math lesson like this. So we'll see how it works. Alright, you ready? Here we go. Alright, so this is what you have to do, is go get your math book. We're still in volume 1. We are in chapter 2. We are multiplying whole numbers still. And we are on page 99. And you need all 3 pages, which is going to give you 6 pages because they're two-sided, right? And 3 times 2 is 6. So we're going to go from 99 all the way to page 104. All right, got them? If you don't, pause the video and go get them. I'm going to keep going. Powers of 10. We're talking about multiplication patterns, right? We're looking for patterns. So what strategies can be used to multiply whole numbers? So we're going to learn some cool little tricks, all right, to multiply whole numbers easily so that we don't have to spend so much time thinking about it. All right, you guys are going to be having to multiply these numbers your whole life. So remember our words that we've been talking about, right? I have 3 words I've been talking about a lot. One is the base. My base is just my number. But when I have a power next to it, right, this power is the little number next to it. When I have a power next to it, it it changes my base, or it changes my answer. My base is my number that I'm going to multiply. So this number I'm going to multiply. This number I'm going to multiply. This little number tells me how many times I want to multiply it. So this means 3 times. 3 times 3 times 3. So 3 times 3 is 9, and 9 times 3 is 27. All right, here we got 5 to the 4th power. So I call this my 4th power. I call that little number up there an exponent, right? Hopefully you guys are remembering these words. Exponent. It's that little number up there. It's called an exponent. They like to call it, you know, the little baby number. Anyway, we have the same one here. Look, same problem. 5 to the 4th power. 5 to the 4th power. It's always going to be 625. You can memorize these things too, just like you do your multiplication tables. And hopefully you guys have them memorized. And if you don't, go do it. Do that. That's what we're going to be doing every day, memorizing those numbers. All right, so 5 to the 4th power is 5 times 5 times 5 times 5 times, sorry, 4 times. So 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. So 5 to the 4th power is always going to be 625. If you see this, that's the answer. You won't even have to think about it if you memorize it, right? But why would you want to memorize it? But you could if you want to. But the basic facts you need to know, like 5 times 5. We also practice doing this on a calculator. So the other teachers are telling me, no, we should not be using calculators, but I think I've been told by other teachers that it is good to use a calculator. So however you want to do it. Here we go. We're on page 99. So we're doing powers of 10. So powers of 10 include numbers like 10, 100, and 1000 because they can be written as 10 to the 1st power, 10 to the 2nd power, and 10 to the 3rd power. And just a little side note, again, I hope you guys remember, if I ever have any number to the 2nd power, it doesn't matter if it's 10, whatever number's there, if I raise it to the 2nd power, I call it squared. So if you see a 2, I call it squared. 10 squared. I could have a 5 squared. Whatever number I have there, squared. If you ever see a little 3 in your exponent is a 3. It doesn't matter what number's here. If your exponent is a 3, I call that cubed. So I could have also said here, when I said 3 to the third power, I could have said 3 cubed. All right, so math in my world. Our first example, Pet Paws is ordering more goldfish to sell at their store. Each goldfish costs $2. Use the table to determine the cost of 10, 100, and 1,000 goldfish, right? You might be going, oh my gosh, 1,000 goldfish? I have to figure out how much it costs if they're $2. That's so hard, but it's not. Watch. Describe the pattern. So we're looking at patterns in the number of zeros when multiplying the cost $2 by powers of 10. All right, so I think you guys could do this. Here's the cost of one goldfish. Here's my table. You can see here, cost of goldfish. There's a little symbol there, the money symbol, so you know this is dollars. It doesn't say US dollars. It probably should, but this is our US dollars. $2 for each goldfish. How many goldfish are they buying? If they bought one, my product, right? The answer to a multiplication problem is called the product, right? They like to trick you with big words, but that's all it is. The answer to any multiplication problem is called the product. So 2 times 1 equals 2. You got it, right? Now they want to know how many zeros. Number of zeros in the product. How many zeros are there? None. There's 0 zeros. Right? Okay. Sorry. So now, what if I bought 10 goldfish? So I don't know if you guys don't know this. We can do this, right? I know someone's already out. It's 20 and you've already figured it out, right? But we're going to count by twos 10 times. Ready? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? I did it 10 times. So that is 20. So it's going to cost you $20 to buy 10 goldfish. How many zeros are there? 1. Now I have 1 0. All right. Now I need 2 times 100. All right, we could count 2. Oh, that's going to take us too long. Let's not do that. Let's do our multiplication. 100 times 2. Ready? 0 times 2, 0. Any number times 0 is 0. 0 times 2, again, 0. Any number times 0 is 0. 1 times 2. Ooh, any number times 1 is itself. 200. It's going to cost you $200 to buy 100 goldfish. So, how many zeros? 2. Did you notice there's 2 zeros here and 2 zeros here, and 1 0 here and 1 0 here, and no zeros here and no zeros here. So all we really need to look at is 2 times the number 1. And I know by my identity property of multiplication that 2 times 1, or sorry, any number times 1 is itself. 100 times 1 is 100. 8 times 1 is 8. Whatever number times 1, it's always just going to be itself. So can we try this again? 2 times 1,000. All right, I know someone's already like, it's 2,000, but let's multiply it out. Ready? 1,000 times 2. Again, 0 times 2. 0. Any number times 0 is 0. 0. 0. 2 times 1. 2. My answer, 2,000. So we're going to write 2,000. Don't forget your comma. Right? I count backwards. 1, 2, 3, comma. 1, 2, however many, comma. So how many zeros? 3 zeros. Do you see my pattern? 3 zeros, 3 zeros. The number of zeros in the product increases when the power of 10 increases. Which successive power of 10 adds blank 0 to the product? All right, and here we go again. They want to trick you with a big word. Successive, right? Successive means just the next, the next, the next. So each successive power of 10, right? We did 1 power of 10, 10 powers of 10, 100 powers of 10. So each successive power of 10 adds 1 0 to the product. How many zeros are in the product of 7 times 100? So we might have to do it again, right? We might have to do our math. 1 100 times 7. 0, 0, 7. So how many zeros? 2 zeros. My next one, how many zeros are in the product of 21 and 10? Right? The product is the answer to a multiplication problem. So this means 21 times 10. So I'm going to show you, right, 21 times 10. I know when I multiply times 0, I'm going to have 0, 0. Then I multiplied by the ones place already. Now I need to start multiplying by the tens place. So I don't put any number here. I could leave it blank. I put a 0 here to hold the place value, right? Because I already multiplied by the ones place. Sorry, this is two separate problems. Ooh. Okay, so I already multiplied by the ones place. Now I'm multiplying by the tens place. So I'm starting in the tens place. So 1 times 1 is 1. And 2 times 1 is 2. Right now I have to add these together. I had to multiply by the ones place and then the tens place because I had a double digit. So we're going to add them together, but zeros are always, right? So my answer is 210. So how many zeros are in the product? 1. Do you see again? I had 21 times 10. I had 1 0, because I have 1 0. Times 100, I had 2 zeros, and I had 2 zeros, so my answer has 2 zeros. All right, here we go. How many zeros are in the product of 12 times 1,000? Hopefully some of you guys are like, 3, it's 3, it's 3, right? Because you can count these zeros, 1, 2, 3. But for you doubters who aren't believing, let's do the math. Ready? I love math. So I'm going to take 1,000 times 12. So first I have to multiply by the 2. So I'm going to have 0, 0, 0. And 2 times 1 is 2. All right, now I already multiplied by the ones place. Now I'm going to multiply by the tens place. So I need to put a blocker right there in my ones place. So I line up my numbers because I'm going to add these together, right? So I have to make sure I line up my place value correctly. So I put a 0 in the ones place because I already multiplied by the ones place. So I put a 0 there. And now I'm going to multiply by the tens place, right? Your parents might have a different way to do their math. So listen to their way too. There's a bunch of different ways. We can do a different lattice multiplication another time, but we're doing this. But hopefully you guys learn multiplication with double digits in 4th grade. So here we go. Ready? I held my place for my 1. Now I'm going to multiply by the tens place. So 0 times 1, 0. And I'm lining up my numbers. 0 times 1, 0. 0 times 1, 0. 1 times 1, 1. I got to add it up. I ran out of room. Sorry. 0 plus 0, 0. 0 plus 0, 0. 0 plus 0, 0. 2 plus 0, 2. 1 plus nothing, 1. So hopefully you guys can see with my messy little writing here, my answer was, let's write it again, beautiful, so everyone can see it, right? If I was doing this on a test, that's exactly what I would do. I would move my numbers over here. I'd put a little arrow so anyone who was reading it, right? Remember it says always explain, show me, tell me what you did. I'm drawing an arrow so anyone who can't see that could see. My answer, 12,000, right? We were just proving that I'm going to have 3 zeros in my answer. And I do. Yay. All right, back of the page. So, right, if you didn't finish and I'm flipping to the back of the page, then you can pause. Or you can flip over. And also, you could start writing a little higher so you could see it. I ran out of room. All right, I'm going to page 100 on the back. All right, here we have to go. Find 13 times 10 to the second power mentally. I could also say this. Find 13 times 10 squared mentally, right, in my brain without writing it down. But we have to write, we're writing it down because we're practicing, right? But hopefully you guys will be getting better and you'll be able to do this mentally too. Sorry, I moved the paper up too far. All right, here we go. 13 times 10 to the second power. All right, so 13 times 10 to the second power. Hopefully you guys remember 10 to the second power would mean 10 times 10. So 13 times 100. Right, I have 2 zeros. It might be confusing here because I have a 0 plus the 2 there, but I only have 2 zeros in this number when I write it out. This 10 to the second power is the same as writing 100. All right, I'm going to do a little, I love my little notes. 10 times 10 is equal to 100. Right, hopefully you guys saw that 10 to the second power is equal to 10 times 10. And 10 times 10 is 100. All right, count the number of zeros in the power of 10. So hopefully you guys can see. How many zeros? 2 zeros. Compare the number of zeros in the exponent 10 to the second power. To the exponent of 10 squared, 10 to the second power. They are... Sorry, I read it wrong. Compare the number of zeros to the exponent of 10 squared, 10 to the second power. So the exponent here is the 2, right? The exponent is the little tiny baby number, right? Here's my word, exponent, exponent. The exponent is the 2. And how many zeros are there? 2. They are the same, son igual, right? 2 is the same as 2. So write the zeros to the right of 13. So 1, 3, how many zeros are we going to need? 0, 0. So the product, right? The product is the answer to a multiplication problem. We're multiplying 13 times 10 to the second power is, here's my answer, 1,300, 1,300, right? I could say this number a couple different ways. I could say 1,300, or I could say 1,300, depending on what I want to say. So, are we going to put the, let's put the multiplication all together so we can see it, right? We're going to have 13 times 10 to the second power equals 1,300. All right, next one. Now we're going to have 40 times 7,000. You're like, oh my goodness gracious. But hopefully you know your math facts. This is why I keep telling you, memorize your math facts. Know your math facts. Something times 4 is 28. This is one of my favorite numbers because if you think of the calendar, if my birthday's on the 28th, I just know this, right? So in 4 weeks, there's 7 days in a week. It makes it 28. 4 times 7 is 28. Or maybe you knew 7 plus 7 is 14, and you could see 14 plus 14 is 28. Oh, that would be 4 sevens, right? Because that'd be 7 plus 7 plus 7 plus 7. 4 sevens is 28. I don't know how you could, but hopefully you guys know your math fact. 4 times 7 is 28. Count the number of zeros in each factor. So I have 1 0 here. I have 3 zeros here. 1 0 there. You can see the arrow. And 3 zeros here. There are a total of how many zeros? 1 plus 3 is 4. Right? I have 1 0 plus 3 zeros equals 4 zeros. 4 zeros. So write the zeros to the right of the product from step 1. So my answer, right, I had 28. 4 times 7. Here's my 4. Here's my 7. 4 times 7 is 28. I counted my zeros. I have 4 zeros. So now my answer is going to be the 28 plus 4 zeros. 1, 2, 3, 4. So the product, right, the answer to the multiplication problem is 28,000. 28,000. So let's write it. Let's write the problem so we know, okay? So let's write the problem again. We were finding 40 times 7,000. So let's write it out. 40 times 7,000 equals 28,000. Right, that's what we just did. This was our problem we figured out. All right, sorry, if you're still writing, pause. I'm going to keep going. It says, find each product mentally. All right, here we go. 8 times 10 to the second power, or 10 squared. 8 times 10 squared, or 10 to the second power. 10 squared is 100. Hopefully you guys remember that one. 10 squared is 100. Hopefully whenever you see 10 squared now, you're like, oh, 100. Because 10 squared is the same as 10 times 10, right? I'm multiplying two 10s together. This is repeated multiplication. The exponent means repeated multiplication. Just one more time. Sorry, guys, because I'm like redundant. 5 to the 4th power is 5 times, right? I have 4 5s. I'm multiplying. So here I did 10 to the 2nd power is 10 times 10. 10 to the 2nd power is 100. So the total numbers of zeros I have here are 2. Right? Our book, the way they explain stuff is kind of a little loopy sometimes. So 8 times 10 to the 2nd power is 8 times 10 to the 2nd power is going to be 8 with 2 zeros after it. So 8 times 100 would be 800. All right, ready? Here we go. Next problem. 14 times 2,000. You might be like, oh my goodness. But let's do our basic math back. Without all those zeros, can you do 14 times 2? Right, we're back to our little similar math back to over here. Look, 4 times 7 equals 28, right? 4 times 7 is the same as 2 times 2 times 7, which equals 28. Right, because we've been breaking up our numbers. So hopefully you can see this too, that 14 times 2 is the same as 14 is 7 times 2. So this would be 7 times 2 times 2. And hopefully you see that is equal to 28. Hopefully you can see that these are the same, right? Because my commutative property, I can move my 7 to the end. 2 times 2 times 7 is the same as 7 times 2 times 2, right? Both are 28, right? I'm looking for patterns. I'm making my math easier so I don't have to use my brain to think about this stuff, or even my calculator. Sorry. Total number of zeros. How many zeros? 1, 2, 3 zeros. So my answer is going to be the 28 plus 3 zeros. So I'm going to have 28 plus 1, 2, 3 zeros. I go put my comma, try to count backwards. 1, 2, 3, comma. So 14 times 2,000 is 28,000. Isn't that interesting? It's our same answer we had over here with 40, and 7,000. So 40 and 7,000 gave me the same answer as 14 and 2,000. Interesting, huh? Little play on math there. All right, ready? No, I'm going to keep going. You guys can pause me if you need to. Here's our next. We're doing our independent practice. All right, 13 times 1,000. Do you need to write it all out? Hopefully we got this. How many zeros? 3 zeros. So I'm going to take my 13 and I'm going to put 3 zeros after it. And I'm going to count backwards. 1, 2, 3, comma. All right, this one, 10 to the 2nd power. I know that means 2 zeros. With a 10, it means 2 zeros. I just have to look at the exponent. So 37 with 2 zeros after it. So 37 with 2 zeros. I'm going to count backwards and put my comma. 1, 2, 3, comma. So my answer is 3,700. Sorry, did I say this number? 13,000 and 3,700. I'm going to keep on going. You can pause if you need to. It's kind of a cool snake there, right? It says, let's practice. The snake with his S sounds in there. Let's practice. So 9,000 times 3. Hopefully you know my basic fact. Do you know our basic fact? Let's write it. 9 times 3 equals what? 27, right? There's the little trick. If I add my product together in 9s, they add to 9. 7 plus 2 is 9. So if I do my multiplication correctly with my 9s and add my product together, it'll give me 9. My little trick. Okay, there's 27. How many zeros are we going to need? 1, 2, 3 zeros. So my answer is going to be the 27 with 1, 2, 3 zeros. We'll count backwards. 1, 2, 3, put our comma. 27,000. Next problem. 8 times 10 to the third power. Number 6. Or 8 times 10 cubed, right? The little 3 means cubed. So I know I'm going to need 3 zeros. An 8 with 3 zeros after it. Can you do it? Bam. Easy, huh? Put your comma. 1, 2, 3. I'm counting backwards and counting 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. But I only have 4 numbers, so I'm going to have to count once. Ready for the next problem? All right, here we go. 21 times 10 to the first power, right? I only can give special names to my cubed with a 2, my 3, or squared with a 2. But otherwise, I call that little number a power. I call it to the blank power. So I say 81 is a power of 3 here, because those are the 3's, right? 81 is a power of 3. It's to the 4th power of 3. 3 to the 4th power is 81. All right, here we go. 21 times 10 to the first power, which is basically just 10, but we know that has 1 0. So 21, 210. All right, 9 times 50. Let's do our basic fact first. 9, hopefully you guys know it. 9 times 5 equals, right? If you don't know it, you can count by 5s 9 times. 5, 10, 15, 20, 25, 30, 35, 40, 45. That is 9 5s. 45. All right, so my answer is going to be my 45 with how many zeros? 1 0. So if you're not keeping up, just pause my video. All right, here we go. Ooh, some algebra. Find the missing number, right? In algebra, I like to make these letters. I could have A times 10 to the 4th power. It equals 7,000. I got to figure out what A is. Here, they're just giving me a blank square. All right, are you ready? So I could see there's a 7 here, and I could count my zeros. 1, 2, 3, 4. 4 zeros. So 7. Easy peasy. All right, next one. I could count my zeros here. I have 2 zeros here, and I have 1, 2, 3, 4 zeros here. So I know this one is going to need 2 zeros. Let's do some little notes, right? We're keeping track. I have 4 zeros in the answer and only 2 zeros. So I know this is going to have 2 zeros in my answer. Something times 3 equals 12. 3 times, I don't know what. Let's put an A. Equals 12. Can you guys see if A would be 4? A has to be 4 for this to work. If 3 times, right, because 3 times 4 equals 12. So I know this is going to need a 4. So my answer is going to be 400. And pause if you need to. I'm trying to keep this under half an hour, but I'm already going to go over. Okay, 100 times something equals 900. So I know 1 times 9. I see my 2 zeros, 2 zeros. So I'm going to say 9. Here I know I'm going to have 2 zeros. Oh, I already have the 2 zeros right there. So what number I need right there? Just the 44. Because I already have the 2 zeros in my times. In my number there. All right, ready? I'm going to switch on to the back. Each box contains 10 to the 2nd power pencils. The school store has 15 boxes of pencils. How many pencils does the school store have? Sorry. Okay, here we go. Hopefully it's clear now. All right, so each box contains 10 to the 2nd power. So I know I need 2 zeros in my answer. How many pencils does each school have? So let's write our math problem. We're going to say 10 to the second power times 15. Because each box has 15 boxes of pencils. So this is going to equal 15 with 2 zeros, 1,500 pencils. We got to remember to write our pencils. My next one. Julia runs an average of 15 minutes each day. She has a goal of running 10 to the second power, 10 squared minutes in 7 days. Will she complete her running goal in 7 days? Explain. All right, here we go for Julia. So she runs 15 minutes a day. So in 7 days, how far will she run? Right, we're just going to take 15 times 7 equals, and I like to write my problems this way. You know, I like to line up my numbers. And I know 7 times 5 is 35. So I put my 5 in the ones place. I carry my 3 up to the tens place because I still need to multiply this other number in the tens place, which is 1 times 7, which is 7, plus 3 more is 10. So I know this is 105 minutes. She actually runs, right? That's how far she runs. So can we say, or this is how many minutes she runs. So she runs this many minutes each week in 7 days. So she wants to try, her goal is to run 10 to the second power minutes in 7 days. So let's do that. 7 times 10 to the second power, this is her goal. She wants to run 7 with 2 zeros after it, 700 minutes a day. Oops, I messed up. All right. Well, that's good. Everyone makes mistakes. I didn't need to multiply by 7. I read this wrong. She has a goal of running 10 squared minutes in 7 days. So her goal, she wants to run 10 squared minutes in 7 days. So how many minutes is that? I hope you guys know that's 100. So is she going to meet her goal? Yes. And I can show them, I can explain to my friend. I could say, yeah, if I was showing my friend, I'd say 100 is less than 105. And this is how many minutes she wants to run. And she's already running 105 minutes. All right, next problem. A group of friends bought 7 tickets to a dog show for $30 each. How much did they spend on the tickets? Right, so a group of friends they had to buy 7 tickets. There must have been 7 friends going to the show. Each ticket cost $30. So hopefully you know your basic math fact of 7 times 3 equals 21. If you don't, right, you could know your addition, and you know 7 times 3 would be the same as 7 plus 7 plus 7, because that's what multiplication is, right? It's repeated addition. So 7 times 3 is 21, plus I need to add that 1 more 0 on. So $210 they are going to spend on tickets, right? I just put the dollar sign that lets them know what I was doing. All right, here we go. Next one. 40 times 10 to the what power equals 4,000. Well, hopefully you guys can see there's already 1 0 here. There's 3 here, so I need 2 more zeros. 32 times 10 to what power is 32,000? Hopefully you could count, right? There's no zeros here, so I don't count the one that's in the 10, right? I just need to know how many. So 1, 2, 3. 10 to the what power times 8 is 80,000. So the 8 has no zeros, right? And I'm not counting that 0 on the 10. I just need to know how many zeros, and that's what number I'm going to use as my exponent. 1, 2, 3, 4. right? I'm just writing the little number that would go there because that's what the blank square is missing. My next one, 10,000 equals 10 times how many zeros? This 10 does already have 1 0 there, right? There is 1 0 here in this. But this one I'm counting just the exponents. So the other 3 are going to go right there. All right. How can patterns be used to determine products of a number and a power? So sometimes the way they ask me questions, right? How can patterns be used to determine, right? How do I figure out the products of a number and a power of 10? What's the pattern there, right? The pattern is in the zeros. So, and the zeros are the power, right? That small number, 10, to what power is going to tell me how many zeros? So could we say the power lets me use a pattern, right? We're going to call it a pattern. We're going to use their nice big word, to determine, right? To figure out, to prove. To determine, to figure out the number of zeros. The number of zeros. Period. I'm going to keep going. You can pause if you need to. Okay, next page is the homework. All right, so we're doing it together. I was debating on pausing and just doing the lesson, but I'm going to do the homework too, all in one. Here we go. A truck is already went over 30 minutes anyway. A truck is loaded with 10 to the second power, 10 squared boxes of skateboards. Each box weighs 36 pounds, right? There's 100 skateboards in each box. They weigh 36 pounds for 100 skateboards. What is the total weight of the boxes? Here we go. Find 36 times 10 to the second power mentally. Sorry, hopefully I said that right. 10 to the second power without exponents is equal to 100. There are 2 zeros in 100. After placing the zeros to the right of 36, the product is 3,600, right? I put 36 plus my 2 zeros, and then I put my comma, 3,600. So the total weight of the boxes is 3,600. So the skate truck is loaded with 100 boxes. Each box weighs 36 pounds. Sorry, it's 100 boxes of skateboards. So I don't even know how many skateboards are in each box. But I know that each box weighs 36 pounds. Ooh, there would be another math problem there to figure out. All right, next problem. Find each product mentally. So 7,000 times 500. So if you know 7 times 5 equals 35, then I know 35. I'm going to count the zeros. 1, 2, 3. 1, 2, 3. I'm going to put my comma. All right, here we go. 320 times 10 squared. 10 squared is 100, right? I know 32 times 1. You might want to write it because we're still new, right? So we're still practicing, so you can prove it to yourself. And your brain's going to start, oh yeah, anything times 1 is itself. So 32, how many zeros do I need? Well, I have 1 there. I need that 1. And then I have a little 2 there. So I need 2 more. I'm going to count my zeros. 1, 2, 3, comma. I'm going to count my place values backwards. 1, 2, 3. Put my comma in. Next one. 56 times 10 to the third power. So I know it's going to be 56 with 3 zeros, right? 10 to the third power. We've already practiced that. So hopefully you guys remember this. The third power, I don't count that 0 there. I just count the 3. How many zeros? 3, 3. 1, 2, 3, put your comma. All right, 10 to the second power times 72. So hopefully you remember the 72. I need 2 zeros. I'm going to put my comma. My next problem, 80 times 3,000. So if you know your basic math fact of 8 times 3 equals 24, right? This is one I just kind of remember this one. I pair it in my brain with this one because I know they both go together, right? But you could also do this one. Right? But all of this is going to be, if I could break this down to its basic numbers, it's going to be 3 times 2 times 2 times 2. Right? We're doing our little math facts. Sorry, I always like to do my extra sideways way, you know, right? So this would be the same as 2, because I'll put the smaller number first, to the 3rd power times 3. All of those would equal 24. Well, if you could see, I could break down any of these numbers, right? Because 8 is the same as 2 times 2 times 2 times 3. 12 is the same as 6 times 2, which would be 3 times 2 times 2 times 2. And 6 is 2 times 3, and 4 is 2 times 2, which again, 3 times 2 times 2 times 2. Ta-da! Anyway, so my answer is going to be 24. We're going to count how many zeros? 1, 2, 3, 4. 1, 2, 3, 4. Put our comma. 1, 2, 3, comma. And I am going to say this number, 240,000, right? 240,000. I guess I could also say 10,000, but that doesn't sound right, so we won't even go there. All right, 10 to the 3rd power times 31. So all I need is my 31 and my 3 zeros to the 3rd power. 1, 2, 3, comma, 31,000. I'm going on to the back. To protect themselves from extreme hot or cold temperatures, American alligators dig burrows in the mud. Suppose there are 20 alligators, each with 50 feet of burrows. What is the total length of all the burrows? So not only, see, you know, I love math, but I love when they teach us little stuff here. American alligators. That means they're in America. They protect themselves from extreme hot or cold, right? They don't want to get too hot or too cold. Extreme means really super big, right? If you're extreme, it's big. So they are digging burrows, right? What's a burrow? In the mud. So hopefully you could picture them. They're digging tunnels in the mud. Did you know alligators dug tunnels in the mud to protect themselves from hot and cold? They have tunnels. Interesting. Here's our cute little alligator. Later, gator. All right, here we go. Suppose there are 20 alligators, each with 50 feet of burrows. What is the total length of burrows, of these tunnels these alligators are digging? Let's see. So let's check it. 20 times 50 feet, right? Each alligator, there's 20 of them, they each dug 50 feet. How long did they dig? How big are their burrows all together, right? The total all together. So hopefully you know your math fact. Your basic math fact here is 2 times 5, which is 10. That already has a 0 in it. So I'm going to use that. I'm not going to count that 0 because that's in my other fact. But I need to do these zeros. So I'm going to add 1, 0, 1, 0. And my answer is 1,000 feet. That's how much these alligator tunnel burrows are. So you guys learned a new word, burrow. A lot of animals burrow. Bunnies burrow. They dig holes. Paulita reads an average of 20 pages each day. She has 6 days to read 10 to the 2nd power, right? 100 pages. Will she finish her reading in 6 days? Dun-dun. Can she do it? She reads an average of 20 pages each day. She has 6 days to read 100 pages. All right, so she's been reading an average. Every day she reads about 20 pages. So in 6 days, that'd be 6 times 20 pages each day, right? How many pages is that? So hopefully you know your basic math fact of 6 times 2 equals 12. And then I'm going to add my 0. So that's 120 pages. How many does she want to read each day? Or how many pages does she need to read? She has to read 100 pages, right? 10 to the second power is 10 times 10, which equals 100. So she's supposed to read 100 pages. Will she finish if she reads 20 pages every day? Yes. She'll even would have 20 extra pages. She could read a different book of 20 pages worth. All right, so, and I am going to prove to them, right? Explain it. So I'm going to explain it like this. I'm going to say 120 is greater than 100. So it said, will she finish her reading in 6 days? I'm going to say yes. And then I like to put my semicolon to separate my answers, my word from my proof. Here's my explain. 120 is greater than 100. Maybe you want to add your pages in here. Whoop. 120 pages is more than, greater than 100 pages. All right, next problem. We're almost done. Phew. Right? If you needed to take a break, I should have said that too. You could go anytime and take a break and come back. I should have taken a break. I actually have taken a couple little breaks in the middle. Someone was calling. Explain. All right, here's make sense of problems. All right, we need to make some sense of this. Explain how using basic facts can help you find 10 times 20 times 30 times 40 mentally. How are we? All right, so how are we going to explain that? 10. How are we going to explain to do that? So can we say multiply, that's all they want. They don't want the answer. Multiply the numbers without zeros and annex, remember we're going to put the zeros back on, the zeros back on. And we used one of their words that they taught us earlier. And we don't need to do the math, but while you write the sentence, I'm going to do the math. So, right, I would say 10 times 20 times 30 times 40. I could do it mentally. I'm going to take my 1 times 2 times 3 times 4. So 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. So I'm going to say this is going to be equal to 24 plus 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros is going to be equal to 240,000. They did not ask you to solve the problem, so you didn't have to do that. But if you would have wanted to, because you know I like doing math, you could do that. So all you guys have to do is write the sentence, right? That's all they wanted. Explain how we use it. It says, next problem, vocabulary check. Fill in the blank with the correct term, right? Term is a word or number to complete the sentence. It could be a word, it could be a couple words. So it says numbers like 10, 100, 1,000, and so on are called, right? This is a term. It's not just a word here. It's going to be powers of, I wrote too big. I'm going to extend their line out. Whoop, make it a little longer. I needed more room. So I'm going to call it the powers of 10. All right, last problem. Yay. A music store sold 10 to the third power CDs and 10 to the second power CD players. If each CD cost $12 and each CD player cost $35, what was the store's total earnings? We got to do serious math here, huh? Right? So 10 to the third power was how many CDs they sold. So 10 to the third power. How much did the CDs cost? Each CD cost $12. So this is how much money they made from selling their CDs, right? 12 times 10 to the third power is going to be 3 zeros. And now it says each CD player cost $35. How many CD players did they sell? They sold 10 to the second power, 100 of them, huh? And each CD player costs $35. So I know that means they sold 35 plus 2 zeros, $3,500 worth of CD players. I'm going to add these two numbers together to find out what was the store's total earnings. I'm going to line up my numbers nice and straight. Right? I have to make sure these zeros line up nice and straight. And I'm going to add them together. 0 plus 0, 0, 0 plus 0, 0, 5 plus 0, 5, 3 plus 2, 5. Bring down my 1, 1, 2, 3, comma. Is that one of the answers they gave us? Oh, yay, number A, letter A. Yay, we got it right. Yay. All right, please take a picture of your math tape, front and back, and add it on Canvas. I actually put it on Google Classroom. I mean, I only put it on Canvas. I will try and add it on Google Classroom in case you guys have trouble, but I only put it on Canvas right now for you guys to add it on Canvas. So, yay, done in 51 minutes and 18 seconds.